Okay, welcome everyone. Today we're doing a deep dive into using Apex from Lightning Web Components, specifically focusing on those imperative calls.
Yeah, absolutely. We've looked at the sources, and there are really two main paths, right? You've got the wire service.
Which is great for that reactive automatic data stuff.
Exactly. But then you have imperative calls, and our mission today is really nailing down when and how you use those because they're crucial for anything user triggered.
Like a button click or some complex logic that needs explicit firing.
Precisely. And the key difference, the thing you really got to manage, is the JavaScript promise that comes back. Wire kind of hides that complexity. Imperative puts it right in your hands.
Right. So you get full control over that whole asynchronous lifecycle. Okay, let's walk through it. Step one, prepping the Apex method itself. We know it needs it OR enabled. What else is non-negotiable, especially for, secure code?
Okay, so beyond the basic add or enabled and deciding with sharing or without sharing, the absolute must do, particularly in production, is enforcing security in your query.
You mean field level security?
Exactly. You need to add with security enforced directly into your SOQL query. So if you're, say, fetching contacts.
Selected name from contact with security enforced. Something like that.
Perfect. That ensures the code checks if the running user actually has permission to see the ID and name fields. It's a critical security layer. Forgetting it is, well, risky.
That makes sense. It's an explicit check you, the developer, have to remember to put in. Okay, so Apex method is ready. Now we jump to the LWC JavaScript. How do we bring that method in?
Straightforward import. It's import some local name from at Salesforce Apex your controller name dot your method name.
And that's some local name. Best practice is just to keep it the same as the Apex method name for clarity, right?
Yeah, definitely helps avoid confusion down the line. Keep it simple. So once it's imported, you call it like any JavaScript function.
And that call immediately returns the promise object we mentioned.
Bingo. And handling that promise properly is where the real work is. You need a robust chain.
Okay, so we have the .then part. That fires only if the Apex call succeeds, and it gets the results right.
Correct. Result holds whatever your Apex method returned. That's where you'd update your components data.
But what about when things go wrong? Salesforce throws errors sometimes, but you're saying we need more.
You absolutely need the .catch at Brock. Relying just on generic system errors isn't great for the user experience.
So .catch lets you provide specific feedback.
Exactly. Maybe it was bad input. Maybe they don't have permissions. Maybe a network blip. .catch is where you handle all failures, exceptions, FLS errors, denied by, with security enforced, everything, and show the user something helpful.
Okay, and for success, .catch, for failure. What's the third piece?
No land block. This one is super important because it always runs, whether the call succeeded then or failed.
Always runs. Okay, so that sounds perfect for cleanup tasks.
Precisely. Like turning off a loading spinner or resetting some temporary state, it guarantees that cleanup happens regardless of the outcome.
So this, then, .catch. Finally, structure.
How does using it properly lead to a better, more resilient component for the person actually using the app?
It directly ties into managing the component's state correctly. There are like 3 key pieces of state you really need to manage for any imperative call to be robust.
Okay, what are they?
First, an iLoading flag, a Boolean. You set it true right before you make the call.
To show a spinner, prevent double clicks.
Yep. And you always set it back to false inside the dot, finally block, guaranteed cleanup.
Got it. iLoading. What's second?
The actual data you're fetching or manipulating, say it's a list of contacts. You typically update this contact's property only inside the successful dot block.
Makes sense. Only update data if you actually got good data back. And the third state?
An error property.
Yeah.
This is where you store the user-friendly error message you generated in your .catch block.
So you can display it in the UI. Right. And crucially, you should clear out any old error before you make the new call. Otherwise, a previous error might stick around misleadingly. So clear error before the call, populate it only in .catch.
Okay, so manage eyes loading, handle the data in .cad, and manage the error state via .catch and clearing it beforehand. That sounds like a solid pattern.
It really is. It makes your component predictable and handles both success and failure gracefully for the user.
So, wrapping this up, the big takeaway seems to be imperative calls give you vital control for user actions and complex logic.
But that control comes with the responsibility of manually handling the async lifecycle with promises and diligently managing component state.
And importantly, handling security explicitly.
Yes. Let's leave the listener with this thought. The wire service does some heavy lifting for you, including some implicit security checks. When you choose the power of imperative calls, you must remember to secure that path yourself. That with security enforced isn't just syntax, it's you taking direct responsibility for data access. Don't forget it.
A crucial reminder. Thanks for breaking that down.
My pleasure.